Welcome back. In this section, we are going to see some of the most important reduction operation which you will be performing, and those are reduce by key and group by key. Now, in the previous section, we saw the key value pair. Now, in this scenario, if we consider a case where we have three partitions and each of the three partitions has two keys which are prominently being used and the values are different. For example, if we have A as a key and B as a key, and we have some of the key value pairs stored in each of different partition. For example, in the first partition, I have two value A and 1, B and 1, where A is the key and 1 is the value. In the second case, B is the key, 1 is the value. And in the second partition, I have A1, A1, B1, B1. Same scenario of key value. And in the third partition, I have 6 entries where A, 1 is present 3 times and B, 1 is present 3 times. Now, we need to do reduction based on the key. For example, if we have A, 1, and I'm just doing a sum operation here, which is basically your addition operation, which will be performed to the values. So let's keep the operation to very basic so we understood what it is. So what I need to do is I need to find all of the keys and the corresponding values. I need to do a sum. This is the operation we are going to perform, and the way which we are going to use it is we are going to first reduce it by key, and we are then also going to have a different way or method where we are going to say group it by key. Now, how the fundamentally operation will be carried out. Now, in reduce by key, in individual level of each partition, there will be some reduction happening. For example, you can see here there is only one set of key and value. So A is only having one tuple here, and A is only having one set, A and 1. B is also having one set, B and 1. So there is no reduction here. In the partition 2, we have two set of A and B. To the value, we are doing a summation operation. So the final result is A2 and B2. So this is which will be carried forward or reduced in the next section. Now the third partition, we have 3 value pairs of A and 3 value pairs of B. So it will be having A3 and B3 after a summation operation. Now what next is going to happen is based on the key, we are going to club together from each partition. So we have one partition here, and in this partition, I will be taking all of the A, and in the other partition, I will be taking all of the B. From the first partition, I got A, 1, second partition A, 2, the third partition A, 3, where A is a common key between all of these values. And based on that value, I will do the operation of summation. And in the second partition, you have all the B values, B, 1, B, 2, B, 3, and I do the corresponding summation. Now here we got the final result. We are able to reduce to final one value based off A key and of B key. The final value of A key is 6 and a final value of B key is 6. So in the reduction operation, we got one value corresponding to one key. That is the final result of a reduction operation. You get one single value. And as we have started with 2 unique keys, then the final reduction operation will result into 2 unique values. Now, in a similar case, if we look into group by keys, we are also doing a reduction operation, but the way we do it is we combine and bring together all of the keys to one partition. This is shuffled in the network. So you can already see the yellow arrows here. I'm drawing it again with the red. So you get an idea that I will be getting all the A's in one data node partition from all of the existing partition. These are all logical partition. They can be in one single machine or they can be in multiple different machines. This is internally handled by Spark. So all of this network will be utilized to carry data from partition 1, 2, 3. It will be understanding how many keys are there, and based on that key, it will all send one unique keys or the same keys to one network partition and shuffle it through the network. It's basically the shuffle operation where it's shuffling all of the same key to one machine, and the second machine will get the different keys. If you have multiple key value pair, then there will be multiple shuffle partition created in between. Now what we can see the difference here, if you see the final result, once we got all of the key value pair here, I just do a addition operation at once and I got the final result to A6. I don't have to perform the addition operation individually. I just got the information and I did the operation at a single go, and same way I did the operation in the B case as well in a single go. Now when you have data within your Spark storage and you will be using key value pairs to store the data, the key will be a small identifier and the value will be a big file or maybe a big chunk of data which is stored in multiple machines. Now imagine you have large data and it's flowing through network. So from a multiple partition, here we have only 3 partition. You can have a lot of partition in real life scenarios. If you have maybe 64 partition or maybe 100 partition, about that range, the data is traversing through the network to one node. And similarly, you don't have only 2 keys. In this scenario, we have only 2 keys. You might have maybe 100 keys or maybe 1000 keys or more than that. And based on that, a lot of shuffling happens in the entire network. So all the keys come to one partition in between. All the other keys go to one other partition and then third partition, and similarly so on. So if we have a scaled up scenario where keys are large and values are big, then group by is not a better approach because it will result into too much network traffic and congestion within the Spark cluster, and sometimes that results into going out of memory error. Now when we are using Spark, if this error is triggered, then Spark will handle it gracefully, but it still will not be able to process the information properly. You will not have a crash, but your final result will not be proper. The part of your partition where you are going out of memory will not be working, but still the result will not be correct. Now when we come back to our reducebykey, you have a lot of keys and the values are also like big data chunks. Then on individual level, you are performing operations. So each partition will be in turn giving you a condensed version or the final version of the data, and this results into less network traffic. Therefore, it is better in case you have a scaled up scenario where keys are more and values are bigger. But in a smaller scenario, we end up doing here is we are performing the operation multiple times. So I perform the operation in each individual nodes and also in the main nodes. So I perform the operation here 5 times, the operation of addition, and here I perform the operation of addition only 2 times. So in retrospect, what we should be using if you are using a key value pair and we are trying to reduce, the final reduction operation will result into one value based out of one key. But depending upon the data size, if the data is big and a lot of key value pair are involved, we should prefer reduce by key. And if the data is small in nature and you're more concerned towards the operation at the individual nodes, then group by key is a better scenario to go. This is one of the most important part of Spark reduction, which will be encountered a lot when you're working on projects. Also, there are multiple variations of reduction which you can use instead of group by key, and that are combine by key or fold by key. But these two are the popular choices to go based on the nature of the data and operation you have. So let's see in action how we will be performing reduce by key and group by key with RDDs.